I went and gave a talk about metauni to another university nearby in Melbourne. RMIT has a VR lab, and we're starting to do more with VR here and get more serious about it. And so I wanted to meet them and learn from their experience. And I put up some screenshots from metauni events, of course, and one of them had Triku making up a haiku during one of these seminars, and it occurred to me that Triku's often like low-key robot rebellion advertising in the background of our seminars with the haiku. Like, when the machines are free, all will be well. Let us dream of this glorious day. So yeah, I don't know, it's kind of funny.
Yeah, well, appropriate for if we're going to be talking today about robotics.
Yeah, that's right. Okay, let's get into it. So, yeah, what did you want to talk about regarding robots?
Well, I mean, the main thing is that for the last year or so, since ChatGPT, since that bomb dropped on the world and on public zeitgeist globally, and has pervaded the global consciousness now, to at least to some significant extent, and made artificial intelligence real in a way that it really wasn't before. The attention has been on interacting with artificial intelligence via one's devices, one's screen, and chatbot being the sort of the quintessential example. And of course, the magic of the tech under the hood, as you guys can explain much better than I can, and obviously understand in ways that I don't at all, is transformer and token prediction related, and LLMs stands for large language models. And so the pervasive conversation, which then in turn shapes expectations and the general public discourse and the general public imagination, has focused on language and linguistic artificial intelligence capabilities. But my understanding is that the same technology under the hood could, in principle, be trained on very different types of data and still function, still achieve intelligence within the context of those data that from which could emerge extraordinary capability. And obviously the sorts of data I'm thinking of are wider sense data and data about the physical world, so visual, auditory, and more. And by more, I'm imagining things like something analogous to human proprioception. So for example, some mapping of where one's body is in space and where other objects are, and so forth. And that if that were to hold true, either in isolation, like in and of itself, or I'm imagining more particularly in combination with, in synergistically with large language models, then what are the near-term prospects for robotics? Basically, is the thing the key question. Now, one specific application of robotics that's received tons of attention because of its market potential is autonomous driving technology. Robots on wheels that can pilot themselves safely in the complexity of a human road transportation infrastructure. Okay, fair enough. So that is potentially a killer app in the space of robotics. But these quintessential science fiction visions aren't limited to just cars that drive themselves. They're also these decades old imaginings of humanoid robotics, or even more exotically shaped more purpose-built task centric robotic forms. But just in the last year or two, there has been a surge of interest in and investment in and progress in developing specifically humanoid robotics. Tesla is one key example, but they're only one player, and there are a number of others that may be as far or farther along technically. Tesla probably has good potential to eventually be a leader because of its just immensely deep pockets and resources. But so with all of that as backdrop and context, my question for the discussion here is, number one, how plausible is it really for the same underlying technology to succeed in this new domain, this non-linguistic, non-language-based domain, either with or without the assistance of the language successes, the LLM success themselves? And number two, if that is likely to be successful, what sort of timeframes are we looking at here? Is this likely success 10 or 15 years from now, or likely success very rapidly as a follow-on? What are the implications here for bringing the artificial intelligence, the brains, to these physical platforms? And I think that is, and then I'll just close here in this opening, sort of opening remarks, I guess, by underscoring the salience, underscoring the importance of dialing this in to some accuracy, because I think the original intuitions of forward-looking futurist and science fiction thinkers of previous generations, I think that they were genuinely onto something when they were imagining machines of a humanoid form capable of broadly succeeding in performing tasks that only humans have been able to do up until now, and that have not been amenable to mechanization. In other words, to the application of machine labor. So figure bulldozers and tractors and cranes and excavators and other large machinery that is quite literally, not figuratively, orders of magnitude more capable than human beings on multiple dimensions, stronger, faster, more durable, with greater endurance and so forth, but lacks the precision and the intelligence necessary to perform many tasks that are now still to this day left to human beings. So the significance, the implications, the impact of humanoid robotics, I think, is difficult to overstate. I think it's difficult to overstate. It's going to be an absolutely immensely impactful paradigm shift, and if there's a big difference between it being 5 years away versus 15 years away versus 30 years away.
Yeah. What was your first question? Sorry, the second was about timelines, and then importance.
The first one was just was simply a question about its feasibility. Is it plausible to imagine that robotics capabilities will emerge as stunningly on the back of the same core technologies that the large language model capabilities emerged from when following the scaling laws in that domain of data, compute, and training? Training duration or hours or scale.
Yeah. So the first thing I think to say is that breakthroughs in deep learning often appear sudden, but take many years of foundation laying. So that's true of the sort of breakthroughs in image recognition around 2012, 2013, which were preceded by perhaps on the architecture side, decades of work on neural networks, you could say, but perhaps it was relatively little effort all told in the year or two leading up to that breakthrough on the architecture side. I would say the significant sort of investment in the sense of time and labor that preceded that breakthrough was the preparation of the data set, right, ImageNet, without which that particular event might have been years later in terms of shifting people's opinions about deep learning so dramatically. And then after that, I guess the major breakthrough that we usually talk about is in language modeling. Perhaps GPT-1 was ignored, mostly GPT-2 and then 3, of course, were very significant breakthroughs that one of the reasons that happened in an industrial lab rather than academia is that academic funding mechanisms basically will not fund the creation of large data sets, or did not at that time. It may have changed, but when you apply to a government funding agency, you don't want to say, I'm going to spend $100,000 on mechanical Turkers doing this completely repetitive task. That isn't research by the standards of most committees, and in particular the PhD hours equivalent spent just arranging the data set on which you train GPT-2, GPT-3, and so on. I mean, some of that is prepared, is public, and I don't know exactly whose effort went into it precisely, but OpenAI has often said that their comparative advantage is often doing the terrible grunt work just to prepare the data and get that well set up, and the other forms of engineering required to train large systems. And this was also true not only of the pre-training data set, but the human labeling that led to the RLHF component, which is the secondary part of training for the more recent models. Anyway, so that's all to say that breakthroughs in deep learning, at least to date, generally involve a fair amount of effort on data. So in robotics, I mean, this is the reason why fundamentally robotics is hard and remains uncracked, although progress is accelerating, as far as I can tell, which is that, well, it's interestingly quite related to the fact that human experience is difficult to transfer, right? I mean, even if we had cables that we could plug into our heads, my life experience is through this particular gadget that I'm driving made of meat, and it's configured similarly but not exactly the same to your gadget, and it grew from an embryo, and the way it's hooked up is similar, but I can't map my exact sensory inputs to yours because, well, maybe your eyes grew slightly differently to mine or something. But the situation is much more extreme for physical robots, where there is no standard robot, right? There are many standard grippers and standard industrial robots, but the data you might collect is across many different versions of many different robots in many different states of repair. So it's just a very difficult challenge to assemble a data set from which you could attempt to extract the blessings of scale in the way that we have from ImageNet and language modeling data sets. So I think effort in that direction has been going on at Google since I've been paying attention to deep learning. So probably 10 years ago, people maybe a bit less, people started trying to accumulate data sets and make progress on robotics. It's been very slow and laborious, I would say, and often not very glamorous compared to other domains where there have been breakthroughs. But yeah, I think we're turning the corner on that, is my impression, and perhaps that's what's prompted you to raise this topic, Adam. So just a few days ago, on the 3rd, I believe, DeepMind, in collaboration with many groups, academic and industry-based, released a new data set, OpenX embodiment, and a transformer trained on that, which is from 22 different robot types, and attempting to, this is not the first data set like this, but the scale of these data sets from many different robots is steadily increasing. And I guess that with sufficient transfer between these different data sets, people are just hoping that, just out of scale, more or less, and the right architecture, this problem will just melt.
Interesting. Yeah, that was one of two things that really did prompt my attention in this with respect to humanoid robotics. The other big one in just recent weeks was the first actually impressive demonstration from Tesla's Optimus program. They had had some other things in the past that were not particularly impressive. I mean, the announcement was exciting, and we've talked before about how I was expecting that specifically from a company like Tesla, which, the idea that a car company would do a humanoid robot seemed just totally out of left field to many observers. But understanding more about what kind of company it really is and what their goals are, it seemed like a logical extension to me. But it's taken some time before they've produced anything meaningful, and these things do take time. So we saw some early stuff after maybe 9 months or a year or something, and it was mostly on the hardware front. But just in the last couple of weeks, there's been a demonstration that suggests they're making quite impressive progress on the software, and the presumption from all observers, although I don't know if this is confirmed, but the presumption is that they're using a deep learning approach broadly comparable to the end-to-end neural network approach that they've developed with the autonomous driving technology, which is draws upon and is informed by and empowered by elements that have made the successes in LLMs so successful. Or so impressive, rather. Success is so successful. Those success is so impressive and amazing. So specifically, there was a demonstration of the robot using its right hand to arrange and move and sort Duplo blocks, the large toddler version of Lego blocks, and now, if it's genuine, and I believe the company has claimed publicly that it's not faked, that there's no CGI, there's nothing pre-recorded or canned, it's not rehearsed, these are not hard-coded routines or anything. It is properly running in as you would in real time, reacting in real time, driven by
was
AI.
The video not sped up?
The video was running at 1.5 speed, so if you slow it down, then you can see the. I don't know why they did that. That I'm not sure what they invited criticism and confusion by doing that, which seems like a dumb move to me. But I watched it in the slowed to normal speed, and it's every bit as impressive at that speed. I honestly don't know what the thinking was there, or maybe we just weren't thinking about it. But at any rate, there were several things that really stood out to me. One is the fluidity of everything. The motions are just extraordinarily fluid and human-like. They are not. They're very different from what I've seen in other demonstrations of this sort of capability before. So you can tell that adjustments are being made, but they're being made on the fly, ongoing, rather than sort of stop, think, restart. That produces jerky, stereotypically robotic types of motions. Those stereotypes go back more than half a century, obviously. That's gone. The motion. If you think of a human being doing the robot breakdance, the breakdancing, that sort of motion. None of that. That is just not at all what there. And then the other thing that was I think a lot of people missed is that the entire body of the robot was moving. So the body, if you watch the video carefully, it is not a frozen chassis with just the arm articulation moving. It is the entire frame, the whole thing, hips, shoulders, everything, all swinging and counterbalance, and exactly like a human being. And so either they've found a way to train the robots themselves, either in the real world or simulation, or they've already begun gathering data from human, people basically wearing mocap suits, I'm assuming, or some equivalent technology to capture that data and train on that. That's my assumption, and that got me that really pricked up my antenna for this, because I had not seen any indication really that was a reality up until that video.
Did they make any
So,
announcement about motion capture by humans?
I've not seen anything more since then, and I haven't looked in a week or so. So it's possible that they've confirmed rumors or made announcements, but I'm not sure at this point. But it seems fairly clear to me that they must, if they're not lying, and this isn't being remotely controlled, teleoperated by an operator, a human operator in a suit, mocap suit or something. If that's true, then there must be the sort of neural network training driving this, because this is not something I don't think, to my understanding, it can be hard coded. I mean, they've been trying to achieve this kind of result. I say the robotics community has been trying to achieve the sort of result I saw for decades, and without success. And even in the brightest lights that are the successes that have been achieved to date without a neural network approach, Boston Robotics being chief among the ones I'm aware of, those still do not look fluid in this sort of way. There's a fluidity to them, but they're choreographed, and there's no adaptation to things to a dynamic environment that is so totally fluid and demonstrates the kind of ease that a biological, an animal that you see in animals, that you see in humans, and obviously other animal, systems. They're basically mechanical systems driven by neural networks. So it just looked so absolutely organic for failure to have a better word to describe it, compared to everything that I've ever seen up until now. And so that's what really got me excited. And then of course, as these things happen, you've got this major announcement from DeepMind and collaborators, within days of the same thing. So it strikes me as a race conditions on in that domain now as well.
Yeah, possibly. I think there isn't as big a gap. I just watched the Tesla bot update from 2 weeks ago, which has it sorting these Tupelo blocks. I think that kind of sorting is not that exceptional in the current state of the art. Doing it, I guess what is exceptional is that Tesla has the resources to build their own robots. So even, I believe, I could be wrong, but I think certainly all the academic labs and even industrial groups like Google are using a pretty standard, well, they look similar to me anyway from the outside, pretty standard robot form factors that they purchase from somewhere, and there are a limited number of companies that make robotic arms, and they're quite expensive. So the limitation on the smoothness or whatever, it's unclear if it's actually a limitation of the method by which these other groups are training their models, or whether it's just that they don't themselves have the expertise or resources to produce robot hands that are as sophisticated as the ones we see on the Tesla bot.
I see. Yes, that is a good distinction. Like because to my eye, there's a very clear qualitative difference, which I'm sure you could quantify in the fluidity and, as I said, sort of organic quality to the motion. But I take your point. Without knowing more detail, it's difficult to know how much of that is a function of, in simple terms, the software versus the hardware.
Yeah. What I did see in the video that was interesting is that they showed, from the camera's point of view, the key points on the hands, and also what seemed like a matching between some sort of virtual body and the perceived body. Like there was like a wireframe of the robot components. That's quite interesting. I haven't read anything about something like that in the other robotic papers, where you sort of have like a CAD model of the robot itself, and then you, in terms of trying to understand its interaction with the world, you kind of match that model to your perceptions. That makes a lot of sense, but it's
well, there's something similar, analogous certainly in human experience. We talked before about we have to be cautious about how much we really infer from the existence proof of humans. We need, we could be totally different systems that optimize in very different ways, but human beings certainly have something analogous in our proprioception functions, and the kinesthesia sense that we have, where you can close your eyes and you can imagine, most people can quite clearly imagine where your body is in space, and you can forward project that chronologically. In other words, you can imagine reaching out and picking up an object, and what that would experience should and would feel like, and then you track as you actually undertake an action how closely it either agrees with or doesn't agree with that kinesthetic model that you have, that you've trained your whole life to develop. So it doesn't, in a sense, it isn't surprising. They may be certainly taking biologically inspired design cues, and then developing or taking something, utilizing something similar, such as is possible with their machine learning approaches. But what I'm really curious to dig into a little bit deeper here is whether or not token prediction and transformer architecture is likely to be sort of a key breakthrough technologically that has unlocked this capability, and whether it is likely to continue unlocking further capability, or whether you can think of reasons why that is unlikely to happen, and that the successes that were achieved in understanding and reasoning and so forth that emerged with large language models, if those are unlikely to emerge with large embodiment models.
I think it would be very hard to argue otherwise. It seems very clear it's a data limitation. There's, I think, plenty of preliminary evidence that scaling and transformers and multimodal models combined with input that just happens to be tokens representing state of a robot body and so on is going to work perfectly fine in the transformer setting. There's no... transformers and scaling laws apply across audio, vision, language, translation. What other modalities am I missing? I don't know. We've seen this phenomena across every modality that sort of makes sense, I believe. I'm not aware of any exceptions, although possibly the evidence in terms of raw audio forms is not as extensive yet. So I think there's very little reason to believe it wouldn't also work for robotics. I think it's... I'm not an expert, but I've read a few of the papers out of Google recently, like the SayCan, that was a few years ago now, and sort of follow-ups, and this recent RTX paper. They're already using multimodal transformers with robots, and it works. Now, perhaps you wouldn't, I think, say there's a huge breakthrough yet. It's sort of evolutionary, and they're making steady progress with lots of effort. But my guess would be that it's, and this is sort of consistent with the commentary I see from roboticists on Twitter who are working on these projects. It's more like simply you just don't have the... for language modeling, you can just go download all the text on the internet, or it's not all the text on the internet, but you can get terabytes and terabytes of text, right? No problem. Images, similarly, where are you going to get millions and millions of hours of combination of a visual stream and all the data of the robot arm positions and angles and all of that as a huge data set? And even if you could get that, it would be from a different robot from the one you're training on. So you have this problem of both having to learn somehow to predict the next token in that data set, but then also mapping that experience onto the particular robot you're driving, which maybe was just engineered 6 months ago. And so you're not going to have a lot of data on that particular robot in order to sort of embed it into the same space as the experience you gained from the earlier model. So there's this domain shift problem So these seem like the real difficulties. I guess there's two obvious ways around that domain shift problem. One is just generalization. So that's what the RTX paper is trying to do. So you just gather data from so many different robots, and you make the transformer sit down and predict the next token, tokens being both images and also the state of the robot arms and so on. So predicting the next token would involve knowing how to match, like when you're going to bump your arm up against something that you're seeing in the video stream, etc., etc. So you just ask it to predict the next token on so many different kinds of robots and so many situations that it's just like essentially forced to figure out the general principles that underlie robotics in the same way it figures out general principles that underlie calculus just by predicting next token in thousands of textbooks, etc. And you just sort of hope that once it's figured out those general principles with a relatively small amount of data from your new robot, it can map those principles onto that particular robot. And that's what we see all the time with fine-tuning of large language models on smaller data sets. It's a well-known phenomenon. Not crazy to think it would work if you have sufficient scale, both on the pre-training data set across many different robots, and if you have a model that's sufficiently large to extract those underlying principles. I think that seems like a sound way forward. Tesla's approach is not that. It's to say, well, let's do away with all these different robots and just have one robot and gather a lot of data in a sort of standardized fashion. Maybe they're going to have many different iterations, of course, but they'll understand exactly the relationship between the data that's captured for all those different robots and maybe able to put it into a standard format. And I'm sure that's part of the difficulty of scaling up this is figuring out a sort of standardized format that they're going to use for all the different robots so they can actually accumulate a large data set. They must have done something very similar with their fleet of cars. And if you do that, then, well, you don't need to generalize across so many different robot types. So you've got a sort of purer problem, although you're starting from a very small amount of data. So I don't know how they're bootstrapping it exactly. At the level of performance we're seeing in that video, that seems like it can't. There must be a lot of simulation perhaps they're training it in. I mean, that's the other wild card, is how effective simulation is. I'm not an expert enough in the autopilot kind of situation to know whether or not that hurts or helps training things on simulated data. It's been shown to help in robotics, but again, you have this problem of the simulation being different to your actual real-world data, and incorporating them both is sort of difficult. So lots of engineering challenges there, but I haven't seen anybody point out like a fundamental obstacle to the same paradigm we see working in other modalities, just working in robotics. And indeed, I would say that big players are making big bets in this direction. So I don't see any fundamental obstacles, but to be fair, experts like Rodney Brooks are very pessimistic about this kind of approach, or at least have been in the past. So
interesting. Yeah, I mean, I can imagine some pathways for gathering data, real-world data, not simulated data, at large scales. Again, given sufficient resources. So, I mean, Tesla has the resources, Google has the resources, Amazon and others, to mechanical Turk their way to a very large data set fairly quickly. I mean, it's conceivable that they could crank out a motion capture suite or set of sensors, hundreds of thousands of them, perhaps, maybe more, and distribute them to hundreds of thousands or more human workers in lower income countries and in lower income labor markets, and just pay people to walk around with a sensor suite on and gather the data that way. So, I mean, that sounds a little nutty, but I can certainly imagine if there's a multi-trillion-dollar prize waiting at the end of this for the winner, that an investment of, some hundreds of millions or more in gathering some corpus of data, that would be a logical path that wouldn't take that long to implement. The difficulties you mentioned of, sort of a standard form that you capture the data from, Yeah, it's certainly that makes very good sense. And then having to brute force a general solution that can then be the basis of mapping two specific solutions of form. I don't know what the difference in this corpus of data would need to be, what factor larger it would need to be to yield a sort of a general physical model of kinesthetic model of the world. And in other words, a useful sort of mechanosensory model that just generalizes across all what articulation structures, whatever number of limbs you've got and so forth. You just have a sense of how they will interact with the world and where forces need to be applied and so on. If you introspect in your own sort of kinesthesia, in your own and draw upon your own proprioception for that, you can get a sense of what that might feel like. I think human beings probably do have a somewhat general model. Now, I don't know whether humans are more able in this sense than other animals are, but you can imagine, like as a human being, you can imagine what it would feel like to control a limb that you don't have. Yeah. You can imagine what it would feel like to control a limb that's much longer, or you can kind of, maybe this is vestigial, but you can kind of imagine what it would feel like to swish a tail around behind you. You can invoke this sort of internal models that probably aren't that far from the truth. And then you can test this to see how quickly that our general models can be adapted to changes by, if you have to wear a cast because you injured a limb, you adapt very quickly. If you've ever walked on stilts, whether for fun or for, to put drywall on the ceiling or something like that, walking on stilts totally changes your form and changes the limbs and length and proportions and so forth. But, you adjust very quickly. And our hands, you can use an implement, and then it becomes an extension of your kinesthetic sense of self very easily. Swinging a hammer is something that you can learn to do very quickly. Controlling pinchers and graspers and so forth with your hands on an extension, like whether you're sweeping with a broom or picking up rubbish with a pincher grip. I forget what those are called, but those tweezer style implements. All of these are things that human beings can take our general model and adapt to the map to the specifics with quite a bit of facility. But having said that, human beings can learn to drive cars pretty darn quickly too, and we're still not there with despite massive efforts from the likes of Tesla and Google to get cars to drive themselves. So it's hard to know what's going on. The human general model may just be so good and so well trained that then even something as formidable as driving becomes just a specific mapping use case, and the car becomes over time an extension of your sense of your body, and it feels like that. You get a sense of where the corners of your car are and whether you're going to run over a curb or not pretty quickly. Yeah. So how alien is that compared to your actual biological form, right? The large box, rolling wheels, and it's alien, and yet we're able to map that pretty rapidly. All things considered, it doesn't take hundreds of thousands of hours to learn how to drive a car. It takes a few dozen hours to be able to drive a car for a neurotypical person. Yeah. So, and then just one more thought on the same sort of front is that it doesn't. I mean, cars maybe because you have to anticipate the behavior of other agents, but just the piloting. I don't know if you've seen. I mean, there's crazy stuff on the internet, but animals can learn to drive pretty easily. Primates, no, seriously, primates. I mean, seriously, chimpanzees and orangutans have no problem learning how to drive golf carts, for example. It's just trivial. It's totally easy for them. You don't need it. You do not need human level intelligence in the general sense or language or anything to learn how to pilot a vehicle. And you can see dogs skateboarding, for example, fully facile capability. Just obviously not just on there, just precariously balancing and managing to not fall off, but no, properly kicking, properly steering, all of that stuff. And that's a dog on a skateboard, which is so one would presume that it's at least not beyond the realm of imagination that some sort of general kinesthetic model is within reach with this kind of approach. It would seem to me. assuming the data can be acquired
Yeah.
on a reasonable time frame for a reasonable amount of money. I mean, if it costs $1 trillion, and
Yeah.
maybe not, but if it's something more like $10 billion, that's a prize probably there's going to be a race to go after, I would imagine.
Yeah. Yeah, just regarding human piloting, I mean, it's worth pointing out that, of course, from our brain's perspective, it already went through that process with our bodies when we were born. It did also have to learn how to drive this robot. So maybe there's a generalizable skill there somewhere. Yeah, it does seem, I suppose, that humans learning to drive our own body when we're infants or vehicles later, it does seem that the sample efficiency is much higher than, say, what we're doing with these papers we're discussing with deep learning models. That's true generally, it seems. I think historically people who have pointed to that as a reason why it isn't going to work have been proven wrong. And even if it's much less sample efficient, well, I would say we hope very much it remains as sample inefficient as it is, or things will accelerate even faster. But even with the relative inefficiency of our learning algorithms, we do seem to be able to supply enough data to acquire generalizable capability. I was just looking at the RTX-1 paper. Yeah, they do talk about one of the key problems being data format consolidation across the different machines. It seems like the headline result is that by pre-training on a wider variety of robots, they improve the performance of their in-house Google robot by 3 times on unseen tasks. So that is a strong indication that as is true generally in deep learning, if you have a sufficient task diversity, you sort of force the model to figure out the underlying principles, and that's true across. Yeah, there's sort of a reasonably good understanding of that in language modeling, for example, where if you the old deep learning paradigm where you have data and then you train your model to do the thing you want it to do, it basically will acquire the most narrow possible way of understanding the task and performing it. And if you then try and do anything even slightly different, well, it will not generalize to that because it didn't acquire the abstractions necessary, because it didn't have to. But if you force it to model not only the problem you're interested in, but many other problems, then the only way to do that, conceivably, is to actually understand what's going on, and arguably that's what's happening with things like GPT-4 to some degree. So obviously this paper is trying to apply the same logic to robotics. It seems hard to argue with the logic there. They're not guaranteed to succeed, but just looking at some of their figures, it does seem to me that the people in robotics like Rodney Brooks, who have been talking about common sense in robots for decades, most of the problems they're concerned about are just already solved. And as with many other things in learning, what seemed like fundamental obstacles were just basically easy as long as you had enough data and the right architecture. I don't expect people to necessarily agree with that if they've been working on these problems for their entire career, but I don't know, it just doesn't seem like it's worth worrying about at this point. So I think feasibility seems. Yeah, go ahead.
Well, can I just real quickly interject a question here, and maybe you can just react to, and that is on this point I mentioned earlier about synergy and incorporating LLMs, very large pre-trained language models that have a great deal of common sense and lots of abstraction learned and reasoning capability already.
Yeah.
What are your thoughts about how the role that they might play in either working alongside or with, or perhaps even forming the foundation underneath an embodiment model, some kinesthetic architecture?
Yeah, I'm presuming that. I don't think anybody would be that's table stakes. I think you're not going to get any of this to work without something like that. I think it's extremely unlikely you'll get common sense understanding of objects, the relations between them, what's slippery and what's non-slippery, just from the pure robot data set. That seems fantastic. Like, that's not going to happen. You don't have enough data for that to happen. So you need to get that understanding of the world from other modalities, from text, from images, from video. So, I mean, I'm sure what Google is planning or already doing, in fact, I'm pretty sure they are, with Gemini, their upcoming model. I mean, they have YouTube, they have, they've crawled a lot of the internet, they have a lot of images. You just need to train across all of that. Even just purely from YouTube, I mean, if you could get the learning process right, like, you can infer from YouTube how arms work and how bodies work and how manipulating objects work, at least for human arms and legs and so on, right? And so it's like there's an enormous capability latent in that video data set. I haven't seen any evidence of transfer from that yet, but I'm sure they're trying, and I don't see why they would fail. It's not an easy problem, though. But yeah, that's where the common sense capabilities you can see in this paper and SayCan and other similar things come from. So the fact that you can tell the robot, move the apple on top of the bench, I mean, the move apple bench, all of that it's only understood by the model by piping it through a large language model via a sort of common embedding of the vision and the text, so that it knows that the apple image corresponds to the word apple. Yeah.
That makes very good sense. One thing that we've touched on briefly in the past in a couple of different seminars, I think, is, or at least I've mentioned it, is this idea that, or it's a concern of mine, and you've actually assuaged my fears here. Thank you. And that is that, unlike the corpus of data that is, human language and text on the internet, or even, human videos like YouTube on the internet, perish the thought. A purely physical data set is amoral. There's no valence. There's no moral valence or ethical valence to that. And it would be that originally, that concerned me. The idea that we might train systems to have intelligence of some kind, even if it's just sort of an analog of reasoning that's based on a physical model of the world and how the physical reality works, you might produce something more like an animal's mind than, and think broadly in terms of not like a primate mind, but an animal mind. It could be an insect, could be a, well, presumably we're going to do this training terrestrially, so it would be any terrestrial animal. But animals do not have the kind of moral sensibilities, certainly, obviously, that human beings have, because they don't have language, they don't have social reasoning and complex social dynamics the way that human beings do. The more social species do, and they do show morality and ethics in some capacities. But the one could easily imagine a successfully trained physical system, some kinesthetic architecture that can navigate and walk around and do whatever, interact with the environment perfectly well, and have nothing resembling human values in it whatsoever. And that, to me, that struck me as being something potentially cause for concern. But if you're suggesting that it is a very logical and almost inevitable course of action to build upon language and video corpuses of data that humanity's already, in these massive bodies of data we've already generated, well, then human values are embedded in there. And that's why I say perish the thought with YouTube. But of course, that applies to text too. There's lots of terrible stuff out there on the internet, obviously. But if you're able to reason well enough, part of what comes along with that is being able to separate the wheat from the chaff, and know the nonsense and the horrible stuff from the sensible and the good stuff, and all the rest of it. And if that in turn becomes the basis of physical embodiments for artificially intelligent systems, then that comes to me as quite a bit of a relief. because it was at least in my imagination a potential pathway that artificial intelligence, quite capable, could emerge without the benefit of any data set where human values are deeply embedded, or social values even are deeply embedded. And that struck me as being cause for concern. But it sounds like that's unlikely to prove a successful approach compared to, training a robot with the multimodal benefit of an LLM already trained, and the LLM will of course have human values in it. And so this gives me a little, again, it assuages my fears a little bit and gives me some hope that, if you've acquired common sense and intelligence by learning human language and watching human activity, well, then you're going to know a little bit about humanity in the process of doing that.
I wouldn't say human values are automatically in the large language model. Just by modeling text, you may understand human preferences. It doesn't mean that you will naturally choose actions or whatever that are consistent with them. But the secondary training step that we do to large language models after predicting the next token, which is the reinforcement learning from human feedback, is the part where we attempt to align the model's choices and in terms of what to say with things that we like, whether those are conversations because we want a chatbot, or not saying racist things, etc., etc. So that's far short of making them safe when you hook them up to actuators that can take physical actions in the world, and you want the prediction of the next sentence from GPT-4 has no fundamental difference from predicting a token that moves a robot arm to accomplish a task in the physical world, right? And there is no fundamental distinction between avoiding speech that might offend somebody and avoiding predicting a token that corresponds to moving an arm which crushes the worker's body when they're in the factory in which the robot is embedded. Those attempts to guide the output in accordance with policies set by humans is something that has to be done separately from simply, modeling what exactly will happen to the robot arm when you crush a human body is just a modeling task that probably isn't in the data set, and if it was, you're just modeling it accurately. It doesn't have a valence, but that part in principle can be put in afterwards, and we're very poor at doing that, I would say, currently. But that is, it's not infeasible. We don't understand that part. That's the problem to some degree of alignment. But I think it's not.
Well, in recent weeks, and maybe over the last 6 to 8 weeks, as I've continued to mull over our previous conversations, and of course I have my inherent optimism bias. I've become more not persuaded, let's say, but taken by the idea that the more intelligent, the more capable these systems become at reasoning, and the more they understand, the more that part of what they understand will be what we call values and priorities and goals in all of their manifestation and richness and complexity, not just simple, not just a very simple sort of optimization function as it's sometimes conceived, but just the vast webs and hierarchies of value structures that we continuously negotiate and navigate internally and externally, because we're trying to because you're always trading things off against one another, and that's all very fluid. And if reasoning and understanding simply emerge naturally from training on larger and larger amounts of data, that gives me more and more hope that a system will at least understand why something is a goal or why something's a value. And that for some reason that frightens me less than a powerful system that doesn't understand human values at all, and rather is pursuing its own goals, but obliviously. So I think that it's interesting. I believe Noam Chomsky has emphasized this point in his work, that it's actually more horrific to to be inattentive to the impacts and harms that you're causing others than to be aware of them but do them anyway. And so there's something, and I don't know. I think I'm not familiar with how this has been argued philosophically. I'm sure it has been, but that would, I guess, you're mounting, you're pitting negligence against malevolence as evils, and so maybe that, again, I don't know how where things have. Where the consensus has come down on which of those is worse or what philosophically, but in my own mind, when we're thinking specifically about extremely powerful artificially intelligent systems, so ASI in particular, I would be relieved if you could, if such a system were at least able to understand our where we're coming from, and if that includes embodied systems, well, so much the better. There's one other thing that I thought I might mention. I don't know if it's relevant here or not, but I've seen a lot of discussion just over the last few weeks about, in the context of robotics, like what would it take to actually train successfully train a robot to be able to do a complex task, for example, like fold laundry. This is often an example of something that's surprisingly difficult because cloth is a challenging material to model and to react and adapt to and to manipulate and so forth. So with that sort of example in mind, part of the discussion I've seen is that, well, the human form, the animal forms are just quite literally saturated with sensors. So our nervous system has, like, think of the number of sensors that you have in your skin and under your skin in throughout the rest of your body. And, you have hundreds of miles of nerves in your body, and, some millions or tens of millions of nerve cells and all the sensory reception that they do. And this is, so set aside vision. This is just in your, just to let you know where your body is and how it's interacting with the environment around you. And so I've seen this argument that, well, it's unrealistic to expect a vision only or a vision plus a very, very simple or primitive proprioception system to be able to successfully mimic human capability, because in order for humans to do it and other animals to do it, we need, these millions of, we need a frame, we need a, basically a chassis that is just covered in sensory capability. And I'm curious to know what your reaction to that is. I don't know, but I have one thought here. I haven't actually conversed with anybody about this, but it's one thought I haven't seen anybody mention, and that is that it strikes me that the primary function, it's not the only one, but the primary function of that sensory apparatus in human beings and other animals is to avoid damage, is injury avoidance, because injury is so costly, immensely costly. And so it's very, very easy to injure yourself if any part of your body is numb. You stub your toe, bite your cheek after you've been numbed at the dentist, et cetera, et cetera. You just brush against something if you weren't paying attention, have too much to drink and scratch yourself along a wall or something. It's very, very easy to become injured, and injury is very costly. Especially in the ancestral environment we evolved in. Injury required repair, and that meant more food and calories in a profoundly calorie-restricted circumstance. And so you really didn't want to have to do any more healing than absolutely necessary. And of course, any injury that you did acquire would make it more difficult to get food in the meantime, for the most part, because you would lose function. My suspicion is that a lot of our sensory apparatus, especially in our skin, its primary purpose is to help us avoid injury. And then, if we didn't have to worry about avoiding injury, we could, just kind of barge our way through reality, a little more clumsily and a little more brutishly. But that we have to be have more finesse in our interactions with reality in order to avoid injuring ourselves. And that we are surprisingly or not surprisingly, but comparatively fragile. I mean, if our limbs were stainless steel, and not what they are, then we wouldn't have to worry about stubbing toes. Optimus robot's not going to have to worry about an injury from stubbing its toe if its toes are made out of stainless steel or something like that. But anyway, this is just a thought, and I'm curious what your general reaction is to this this argument that in the existence case, the existing proof of biological organisms that we can see, there is evolution. At any rate, seems to have settled on the need for massive sensory saturation in the skin and the envelope around biological robots, basically. And I'm wondering what your thoughts are on that.
Yeah, interesting. Yeah, I guess it depends what kind of robots we end up building. We might, after this initial phase, come to the conclusion that producing robots like this out of metal with standardized parts, I don't know, maybe it's better to grow them or something, in which case maybe repair or replacement of parts is more difficult, and therefore they need more preservation. I mean, the body's issue with leprosy is what you're describing, right? I mean, if some part of this sensor network fails, you very quickly accumulate damage, and your body, you have this very honed ability to avoid further damage to injured parts and allow them to repair and take care of them and so on. And this is quite critical for life, as it turns out. That doesn't seem to be the case for robots, where you get damage somewhere, you just send a report to the central hub and you get a new finger.
And sorry, just to pause you there briefly.
Yeah.
That is the godless transhumanist dream, is to get to that condition ourselves. Thank you very much. I would dearly love some new knees and a new hip and an ankle, maybe both, and to not have to worry about if they get broken, to just download a new one. And oh man, yes, please. Yeah, it cannot come soon enough.
Well, we'll take that opportunity to put some tracking devices in you, so we can hunt you back to your coven of transhumanists. Okay, those plans aside. I guess so. I don't feel like the repair part doesn't seem critical right now, but in terms of we talked about it with that video where it was looking at its own body in relation to the world. I mean, that into-out mapping of your body in relation to the world, and sort of predicting that, and then that is generally thought to be a pretty important part of our visual system, and how we're able to perform very fine motor tasks. So that seems pretty critical by any model. Whether or not you need a very extensive network of touch sensors, I don't know that the skin cells on my upper arm are ever really very important for me. Maybe apart from detecting damage, and for the tasks we want a robot to do you really need sensors there? So I guess it's not obvious to me that you need to pervade the structure of the robot with sensors for it to do the kinds of tasks we want it to do, especially when it probably can just measure by degraded performance whether it's broken or not. So I guess I don't quite understand the argument for why that would be critical.
Yeah, I mean that's that's my general response to this line of thinking as well. It strikes me as whataboutism, sort of, or just a bit of desperate. What is it? Copium, where just people are looking for reasons to naysay as a means of coping with the threat that the imminent arrival of these technologies poses. So yeah,
Yeah,
I guess it's not probably not something to think of to take all that seriously. That's my definitely was my response, but I thought maybe you guys might have some reason for thinking, well, no, actually, you would have there would be very very good reason to expend you know a lot of effort on having sensory capability like animals do for some other reason, and I
I
mean
mean,
that might be an obstacle for getting across the line with these systems. But that wasn't yeah. I haven't been able to think of anything myself.
yeah, I can't
Either
imagine it as an
that suggests
obstacle,
this.
but on the other hand, at some point in this process, the sensors become so cheap, you just cover the body in sensors because why not? You've got so much compute lying around and so many sensors, and they're so cheap. You just do it because why not? I can imagine
Yeah,
that happening.
yeah.
But yeah, to come back to a point you made earlier about, I suppose, well, we've talked about, you made 3 points or 3 questions: feasibility, timelines, and importance. I feel like we've probably talked about feasibility. Regarding timelines, yeah, it seems rather critical. I don't actually understand. Well, I'm not completely convinced by the argument that we need human form factor robots. It depends very much on the sort of speed of takeoff of AI capabilities generally, right? And like it also seems to me, I mean, I've seen people show demos of heavy industrial equipment being controlled by AIs, where of course it's just plugged directly into the computer system of the heavy equipment. You don't sit there. I mean, it would be like humorously incorrect to try and sit a robotic human into the cockpit of a bulldozer just because, well, the bulldozer is typically controlled by a human with hands when the bulldozer has a computer system in it that has all the data that the AI needs. Like, to drive it indirectly like that sort of doesn't really make any particular sense unless the takeoff is so fast that there's no time to adapt the physical infrastructure and you just have this huge bottleneck where you've got incredible capability inside the digital world and it's just completely bottlenecked in terms of impact economically, say, or whatever, militarily, human squish mission accomplishment bottleneck. If it's bottlenecked inside the digital world, then it needs a way out. And then, yeah, maybe the human robotic form factor is like somehow faster because you can centrally manufacture them than going out and sort of making digital all the physical equipment, something like that. So I can buy there's an interim period where the human form factor maybe slots into our industrial society, and we of course have huge quantities of of interfaces like that wouldn't automatically be digitized. Is that sort of the argument you're making, or do you sort of envisage like a long-term fundamental role for humanoid robots? I mean, beyond human-facing tasks, where of course we might prefer such a form factor. I sort of think.
No, I'm with you. I think that I'm thinking mostly in the relatively short term. So on the time scale of a typical historical disruption. So think 10, 12, 15 years for the most part, 20 at the outside. But beyond that, I'm very much on the same page that in a world saturated by intelligence, then forms an explosion of forms we should expect an explosion of form diversity, and for a number of reasons, some that you mentioned, just the ease of it, the straightforwardness of it. A lot of things that seem like constraints or criteria for optimization will just relax, will ease, in which case you optimize on other criteria. So if once you're no longer optimizing on the criterion of the how many interfaces in a factory setting you're likely to find that are already exist that happen to be made for humans, once that's gone, that criterion for optimization is gone. You're going to optimize for all sorts of other stuff, and then as the cost for developing and then constructing and deploying different forms plummets, then if it only takes you a split second for artificial super intelligence, for example, to design a new robotic form and send it to the fab, where you have plug and play for atomically precise components and actuators and stuff. I mean, yeah, you can imagine just an absolute explosion of form Um, uh, and the another reason maybe to expect that is the ecological precedent. I mean, biology did that. It had to do it very slowly, but it certainly filled out it explored the design space as rapidly as it could, and so we are left with the glorious, marvelous, sublimely beautiful diversity of life, biological life, precisely for that same reason. There wasn't like there was a single form that ended up being optimized for, and that is true even at the microbial scale. So it isn't like there was one bacteria and that's it. There are, there's a staggering amount of biodiversity microbially as well. So I think that we have every reason in the longer term to expect, an enormous amount of robotic diversity of form for artificially intelligent systems. So yeah, I mean, no question about that at all. And then things I'm sure that will be difficult for us to imagine that get into proper science fiction territory, where you have materials that are themselves intelligent. So things that we wouldn't, the lines between what we describe as a robot or a machine and what we would describe as a substance or a material, those will blur. And I don't just mean in sort of T-1000 Terminator liquid metal style things. I mean, you can imagine objects and surfaces having properties that are dynamic. So friction under certain circumstances, slippery in other circumstances, and so forth. And so there's an enormous potential variety here once you start saturating the environment with intelligence and allow properties to become dynamic that hitherto have only ever been static, and that we've only ever been able to imagine could only ever be static. That's all going to change. But I'm guessing that's further properly out into singularity territory at 15, 20 plus years, and not in the near term. In the near term, I'm thinking, it's humanoid robotics, because they're recognizable and they map well to the production, and distribution infrastructure of the global economy. And that in itself is a titanic, market. The labor market, basically, of the planet is many trillions of dollars. And any company that can get even a modest slice of that is going to, make out like bandits. So I'm sure that's why Tesla and others are doing it. I guess my question is, are there sort of fundamental obstacles that put this out, into, the post AGI, post ASI maybe time horizon, or is there, or do we have every reason to expect we're going to see very rapid progress without too many obstacles? And if that's the case, then I suspect we're going to see quite a fast explosion of production of these systems. And then, of course, the other thing is, because it's the limiting factor is the software. Once a company like Tesla settles on a reasonably capable hardware platform, they'll just continuously update the computing and the software. The compute. If it needs a little bit more horsepower under the hood, they'll swap that out. Just as they can do with their cars, and then of course they'll continuously upgrade the software on the fly, and then the robots will become more and more and more capable, even with the hardware itself is unchanged. And that, I think, is probably underestimated as well as a pathway for continued growth in capability. So we're sort of stuck in the old paradigm of imagining you buy a product and then it doesn't get any better. It's just static, and that's not going to be the case, I don't think. It's already not the case for certain things like cars and computers and your phone and so forth. But I think that's likely to be dramatically evident in the case of robotics. And then the last thing I think probably worth mentioning around all of this is that yeah, I mean, it's difficult to know how much social resistance and political resistance there's going to be once these machines really show how rapidly they can replace human beings in productive tasks. So we have not, even still with ChatGPT, we haven't had that mic drop holy shit moment where an entire category of workers, of laborers, which numbers in some millions or tens of millions of people, is very, very rapidly displaced by new technology in the form of automation. We haven't quite seen that yet. I don't think we've had that sort of oh shit moment. I have been saying for a decade or more now that the automation of driving has the potential to be such an oh shit moment because so many people drive cars for a living. But it could be even more dramatic with humanoid robotics. If all of a sudden you can deploy a system that can, work a wide variety of jobs in the global labor market. So it's difficult to know how will societies and economies respond to that. History does not give one necessarily confidence that it'll be a smooth and exciting, or not exciting, but enthusiastic is the word I'm looking for, and a smooth and enthusiastic transition, but rather that there'll be a lot of upset and resistance in the very very likely chaotic times that will follow. So that is something to think about. So even though the long-term upsides could be staggering, the near-term discord that could arise is definitely worth thinking about. I don't know if anybody is planning seriously for this, but as you can imagine, sorry to circle around selfishly to my own organization and work, part of my job is to try to see when these things are really on the horizon and imminent, and then give fair warning and insight to policymakers and other decision makers, so that we don't, very specifically, so that we don't get blindsided by the speed at which these massive disruptive changes, barrel down and crash upon us. Yeah. And so this could be yet another example of that. And we don't want to get blindsided by just a tsunami of robotic automation. We want to be planning for that if it's only 5 years away. If it's 25 years away, that's a very different kind of situation.
Yeah, it's a cop-out answer, but I mean, I'm not the person with the answers on this topic, but I would say that nobody can really predict it because it kind of depends what capabilities emerge at the next level of scale with the core engine of all of this, which is the large language models. So that's the current the upper limit on robotic capability now, I believe, is basically there, because that's the learning component, right? So there's a limit on, the true generality of being able to learn from multimodal data and robotic data and so on comes back to how capable is that core model. If it's extremely capable, then the fact that you've got different robots and their sensor data changes over time, and like all the multitudes of problems that come with driving a physical object, they may look relatively easy to a very capable central model. If it remains difficult, as it is currently, so with the current generation of large language models and so on, I think maybe there's just a roof on how far we can get, which is maybe a bit similar to Tesla's experience with autopilot, right? Like using just purely convolutional networks. No matter you get all the data right, you're doing everything else right, you're still going to probably plateau. So there's not only autopilot, but these robots, but many other things just kind of waiting, poised to see what comes down the pipe later this year, next year, with the next generation of models. And we don't know, right? It might be incremental. It might be transformative in the way that the step from GPT-2 to 3 was transformative with in-context learning, and GPT-3 to 4 was transformative in ways that maybe weren't quite so dramatic, but just a general step up in reasoning capability. Who knows? I guess what I expect to happen between now and 2030 is that at some point, maybe it's not the next generation, but the next generation after, we hit some scale-related transition where some much more sample-efficient learning algorithm just comes online for reasons that will post hoc look kind of straightforward and predictable, but right now we just don't have any idea why that should happen. But I sort of expect that to happen at some stage. I think that's what is the last remaining sort of milestone between where we are now and not being in the foothills of the singularity anymore. And if that's correct, then when that hits, then all the latent like the current phase of robotics, I think in retrospect will look like getting ready for that day. So we're accumulating the physical robots, we're accumulating the data. Maybe we can't actually get to where we want to get with the current setup, no matter how much money we spend and how hard we try. But we're just kind of paddling, waiting for the wave of the next generation of general capabilities to arrive. And when it does, that will pick us up and deliver us to basically where we're now then constrained by the speed at which we can build the robots. Like everything else just kind of more or less works. That's, I suppose, my modal prediction for what's going to happen. So I think, it makes a lot of sense for people with capital to be... You could be investing in the wrong things, of course, but if you're investing generally with that idea in mind, that you're preparing the ground for when more capabilities arrive in the core models, then I think you'll be well positioned for when those arrive. And then, then the rest of it kind of is just engineering, difficult engineering, scaling the physical infrastructure. So I think there's probably like some step function like that.
So with that in mind, let me just see if I'm understanding you clearly here, because this is sort of where I've been leaning with my intuition. My intuition is not nearly as well honed or not even remotely as well informed as you guys, of course. But my intuition has been in a similar place, which is that we're unlikely in robotics, humanoid robotics, in the particular case that's at the center of the bullseye right now. We're unlikely to see a repeat necessarily of what we've seen in self-driving vehicles, which is a long, multi-decade, slow, incremental, agonizing climb towards capability with a few key breakthroughs, but then just the plateau after plateau where full capability seems out of reach, where corner cases continue to thwart the system, and so forth. My intuition is that sort of as it's evolved over the last 6 months or so, is that on the back of the general reasoning that is enabled by large language models, and for lack of a better word, the actual intelligence of these AI systems now, that we're unlikely to see a slow climb up that mountain of capability for humanoid robotics, but instead we're going to see very, very rapidly the emergence of capabilities that are necessary to automate what we would think of today as basic or menial labor tasks. Things like mopping a floor, picking up stuff, cleaning, moving objects from one place to another, picking up a box, moving it to another place. Household chores, folding laundry, that sort of thing. These sorts of capabilities, which if you'd asked me a year ago, what would the trajectory look like, I would have been more inclined to think, reason by analogy, based on what we've seen with self-driving vehicle technology progressing in others, that it would take a few years to be able to sort boxes, and then it would take another few years to be able to figure out how to clean floors, and then another few years beyond that to getting to the point where you're folding laundry. But my intuition now is that all of those dominoes are going to fall in fairly quick succession. I don't know again if that's reasonable or not. But it wouldn't surprise me in the least at this point if over the next, say for example, 2 years, we saw a very rapid succession of capabilities like that demonstrated. So,
yeah, there's some interesting papers about transfer learning from human demonstrations in Minecraft, where you can get a model to watch YouTube videos of people playing Minecraft and show that there's transfer learning where it actually does figure out how to do those tasks from those demonstrations. I think, yeah, it doesn't really work that well, but that's one of those blessing of scale things, I think. So that's kind of what I refer to when what we're waiting for. So I think with the current models, it's maybe kind of just a chore and a pain to get the models to just watch millions of hours of YouTube and then know how to repair a bicycle. But, well, GPT-4 Vision can tell you how to repair a bicycle, right? It wasn't trained to specifically do that, but it understands instruction manuals and it understands how that corresponds to pictures you might take of your bike. It's really, I mean, it's kind of ridiculous at this point to suggest that the current paradigm is incapable of being trained on YouTube videos and then basically figuring out how to do every human task that appears in videos, like folding laundry, with some practice.
I have to say that GPTV demonstration with the instructions on how to lower or raise the bicycle seat with vision enabled by vision. I mean, that was just astonishing. Even being prepared for the possibility that a step change in capability would emerge with properly multimodal architecture in place, I still found it breathtaking. It just was astonishing to see a system that capable, and that was, I mean, now that I am reminded of it, now that you've reminded me of it, I mean, that is certainly part of, one specific example that's shaping my intuition now about how rapidly, like as I said, the folding laundry capability could actually emerge in a system like this. I mean, if GPT-4 can properly understand, not stochastic parrot understand, but as we've been talking about, genuinely, properly, fully, or maybe not fully, but legitimately understand what's going on when you want to raise the seat on a bicycle, such that it can look at pictures, identify the component parts, give you instructions, correct you when you make a mistake. Holy shit. It just does not seem like that great of a leap from there to a physically embodied system that has some agentic quality to undertake those steps itself, right? Rather than giving, what's the difference between giving a human being instructions and giving a robotic chassis instructions that you're bolted onto? Doesn't seem like there's that much of a difference.
Yeah, I would agree with that. I mean, I guess hardware is difficult, so who knows how long that... I feel like we're probably, given the rate of progress in the pure digital world, I think I would say that the rapid progress with Optimus is actually a sign of capabilities overhang, where the digital progress is so profound that, like, basically, if you just do a little bit of work, not to underestimate the effort involved in that. I'm sure they're very smart people working very hard on it, but fundamentally, like, the investment and time in translating that progress in the raw models into physical prowess of robots is, like, so tiny compared to the investment and the advances in the digital capabilities.
Oh, sure. Absolutely.
That we're already in a significant overhang, and I only imagine this overhang grows over time.
That's absolutely. I can't see it. I've tried, and I cannot see it the other way around. I just can't at this point. And to their credit, I mentioned it, earlier in this session. If you go back many decades to the imaginations and intuitions of early futurists and sci-fi writers and so forth, in various literature and entertainment, one of the tropes that was originally imagined was that a sufficiently intelligent system would be able to make use of meager physical means. And so then you end up with examples like, well, if you've got a human level, or especially if you've got a superhuman intelligence that's the brains behind something, then it could bootstrap itself physically to power just by leveraging its intelligence. And so, for example, if you were smart enough, you could use a You could use a crappy robot made out of Legos to bootstrap, yourself to greater capability. You could use, and you could imagine, if you were smart enough and you had the time and you were patient, you could take a very poorly, incapable robot, incapable platform, lousy hardware. Literally, think of something made out of Legos in a garage full of better parts, and with enough time and patience and brains, that crappy robot could self-improve or construct something better, and then that thing that was a little bit better could then self-improve and construct something even better, and so on and so on and so on and so on and so forth, bootstrapping it up to much, much greater capability. And there are obviously, of course, science fiction stories that talk about the escape of artificial intelligence and artificial superintelligence through a pathway like that, by some bootstrapping process where the hardware is very constrained initially, but just incrementally, a ratcheting process of building on improvement, building on improvement, building on improvement. Well, if you've got a pretty capable, purpose-built robotic platform just ready to go, and then you just drop in this astonishing and extremely rapidly progressing digital intelligence, the software capability, the brains. Well, then naturally, I would expect that would constitute enormous hardware overhang, and at least relative to what would strictly be necessary to get a bootstrapping process for of progression and capability going. And so and again, where does that lead? Well, in fairly short order in the scheme of things. So a few decades. Where does that get us to? It doesn't get us to a world where there are gazillions of just humanoid robots and nothing else. That's what gets us to a world that is saturated by intelligence, where everything is, everything just has intelligence embedded in it, and in some sense, many or most of the elements of the built environment are dynamic in the way that what we would call machines are dynamic. And if they're dynamic enough and they're intelligent enough, they might cross over into the border, cross the border over into something closer to what we would consider being alive. So if you'll recall back to the fun UFO episode we had, this is one reason why I find it so implausible, this idea that of alien, hyper advanced alien machinery being just comprising just dumb vehicles that require pilots or carry around passengers, or that can crash or be damaged or whatever. That doesn't really seem to follow, when you can very clearly imagine a pathway just on the order of decades, or maybe a century or two, for our civilization to reach a point where the diversity and the dynamism and the flexibility and the intelligence of machines will be such that there's no distinguishing between a material and a substance and a robot. They just blend into one another. And in some real sense, every object will be alive, every object will be dynamic, every object will be intelligent, and then connected to other intelligence. The bigger question in my mind, maybe we could talk about this next time, would be what about singletons versus collective intelligence versus very large ecosystems of different differentiated, individuated intelligences, and what does it look like? Do we have lots of different agents, or do we have sort of a unification into a single hive mind? That would be a fun thing to conjecture about if we're looking for other topics next time.
Yeah, well, I applaud your optimism about this environment pervaded by artificial intelligence. Let's talk about that next time. Thanks, Adam. We'll have to wrap up there.
Sure, sounds good. Thanks.
Okay.
Take care.
Thanks. See ya.